I'll allow an hour for the test. I think if you're totally prepared for this test, you're looking at around 15 minutes.
I hate when you say that. Okay.
There is no performance-based part to the test. Okay, so
Yes.
their test is really going to go through 3 parts. The first part is going to be everybody's favorite, which is the true-false. Here is, in the true-false section, you're going to have anywhere from 15 to 20 questions that are going to test your knowledge on when to properly use the right command. We'll come back to that in a minute. The second part is in essence really a picking, but it's not a picking section. You need to know really 7 things for it. When we create, and let me kind of express this way, when we create solids, we always start with a collection of p-lines for the most part, right? We don't really use the geometric primitives like box, wedge, stuff of that nature. We start with p-lines. Now, how do we actually take a p-line and create a solid out of it? How do you do that? There's one of 4 ways, isn't there?
Can extrude it,
Yeah, extrude,
loft
One.
it,
revolve, loft,
sweep.
sweep. Okay, so in essence what I'm going to do is I'm going to show you a diagram that has a start position and an end position, and you will need to
Tell you the
identify
commands.
the construction method used to create that solid. Now, once we got a solid, what do we then generally do to finish a part? We do our booleans. So again, you'll have a collection of starting positions and ending positions, and you will have to identify which Boolean operator was used to create those shapes.
So is extrude and Boolean? I mean, I thought
Extrude is not a Boolean.
it's not subtract, addition, intersect.
You have 4 Boolean operators. Okay. We, in essence, really use 3. You have one that was introduced last version. I really haven't had a use for it, therefore I never even really talked about it in lecture. But you have union, which takes all geometry, regardless of where it's located, and joins it together to form one piece of geometry. Doesn't matter how many there are. You end up with 1. You have subtract, where you take an existing piece of geometry, I guess I should say an existing solid. You subtract other solids, and it gives you a final shape. Now, obviously, if those 2 don't intersect physically, it's not going to alter the first one. It's just going to delete the one you're subtracting. Then you have intersect, which takes all of your geometry and keeps the common geometry between all shapes, deletes the rest. Now, the one I didn't talk about, and I'm not sure if this one will really come up in the future and become a viable Boolean operator, is the interfere, which does the same thing as intersect, but on intersect it kept all common geometry and deleted everything else. Interfere creates new geometry of all common places and then keeps all the other parts too. Okay, but it makes different solids out of all of it. Okay. That's going to be the second part. The third part, through a diagram, I'm going to test your knowledge of 3D coordinates and how to navigate the screen. This guy. Okay. So expect some object, expect a grid, expect to have to identify locations on the object, And how do we identify? We identify with the Cartesian grid. I think you can get this one quite well if you understand one thing, and that is that, what is, when you do the right-hand rule, what is the direction your fingers point indicate?
That's why.
Sure. What else do they indicate?
These,
The positive direction of that axis, because that axis is infinite. Like this is generally my z-axis, right, when I'm looking at it this way? That z-axis doesn't run from here to here. It's infinite. It's negative that way, positive that way. Y-axis, positive that way, negative that way, but that axis in essence is infinite, because it's number line. Make sure you review that and you understand what it's doing. All right, back to the first part. I think first, while we're on solids, let's think of this. In essence, what do I consider the most important parts? Number one, when I talked about this, you have to be able to navigate the screen in 3D. And in fact, I mentioned chapter 2, which was your UCS. That's probably the most important chapter we would go through in this entire section. My 2 or 4. For some reason, all of a sudden, my mind's telling me 4. Not that my mind has ever lied to me before.
it's in chapter 4,
Is it 4?
page 84 through 104.
Yes, thank you. It is 4. UCSs. Knowing how to change them and run them. That's the first step in all 3D drafting. Even when I make the comment, stay 2D as long as possible, whenever I did an example, was I still using a UCS and rotating through different views? Yeah, I was, constantly. I was drawing 2D, but I was using the fact of the glass box to navigate to the correct place to draw 2D. You have to know that. It's important.
Do you always, even if you're planning to do, say, a sweep or a revolve, not necessarily an extrude, is it, there, do you still, should you still set up that like 3-sided glass box that you work from, or is it not always necessary?
It's not always necessary. It's object driven all the time. There's a lot of objects you can make completely without ever switching to UCS. Look at the butterfly valve. You have 2. You had the plate, the retainer ring. I don't think you had to switch to UCS to make either one of those 2. But you did have to know where you were starting, which was using that glass box. And I don't know, we kind of primarily focus on our primary views of the glass box, but don't forget there is 3 other sides to it too. That's kind of what you're referencing, isn't it? So, that chapter now. Keep in mind, when we get oblique and inclined planes, I showed you 3 methods off the UCS command to get to those planes and be able to draw on it. There's actually 4 methods. One came up in a later chapter. Remember doing the 3-point? Face an object. You also have the grips on the UCS icon, which in essence will do the same thing as those 2. What came up later, remember dynamic UCS? Where you turn that on your status bar, and then if you hover your cursor over a plane, it automatically defaults to that plane. Pretty valuable tool. It's a new tool, and it works pretty well. Those are all ways to get onto those inclined and oblique planes. Okay, so the number one thing, and this really kind of reverts back to these true-false things that I'm talking about, is chapter 4. Okay, expect me to hit that chapter hard. Expect me to hit chapters 6 and 7 very hard in this true false. 6 and 7 are again extrude, loft, sweep, revolve. The last component of this that I'm going to get hit really hard goes back to the syllabus when I said what's really the main point of doing three-dimensional drafting. It is, if we're going to do it, we need to get working drawings out of it. For us to get working drawings out of it, we've got to understand how to print it. Because 3D is all great and wonderful for us in the office, it doesn't get anything built. We need to go to paper copies. I think Dan maybe made that point yesterday. At some point in time, we do have to communicate to those construction people. And we do that through a drawing environment or a paper environment, at least in today's world. So, know the two plotting mediums. We have view base, which is interactive with the model, view dimension, and paper space. Nothing is two-dimensional in that, right? We draw everything in paper space, not in affiliated with the model. We're just drawing in location. That works great if your model is correct. It doesn't work so great when the model is not complete. And if we're doing little widgets, yeah, okay, we can get the complete model. When we're doing large structures or machines, we can't get the model correct. It's not, we don't have that capability yet, or anybody that's willing to fork over the dollars for us to do that capability. But certainly we have the capability of doing it. I don't know that we have the money to pay anybody to go to that stage. If that's the case, then we generally use the other media, which is Sole View, Sole Draw. Remember, those are used as a pair, where Sole Draw is the projection command and it creates two-dimensional line work that you can then edit. Those three areas, UCS, your construction techniques 6 and 7, and chapter 14, your plotting methods, as well as Sole View, Sole Draw, is going to count for not only upwards of 90% of the true false, it's 90% of the entire test. In fact, probably 98% of the entire test. Because if you've got those concepts, you're well on your way to being a three-dimensional solid model. There will be a couple other items I hit. Solid edit, chapters 11 and 12. How do we manipulate the model once it is created, like the fillet command, the chamfer command, copy a face, extrude a face, sub-object selection will be a small part of the test also. Let me just ask you a question. If I have an existing solid and I choose taper face, copy face, extract edges, color face, what command am I using to do all of that?
Solid edit.
Yeah, I'm using solid edit. They've just given you individual components of that same command. Normally we do a command solid edit, you get all these options on the command line. Each one of those boxes is just one of those options. I think in essence, that's the test and the test review. Does anybody have any questions about any of those topics? And we can explore them in more detail. Okay. Let's go to lights. This is chapter 18. Now, to show lights, what I'd like you to